Epstein, what advantages of elemental digital over hybrid analog or digital array approaches?
Have several advantages. One, taking advantage of Moore's law. There's been tremendous advancements, as I mentioned, in the data converters, just in the processor architectures, and so on. So you can now leverage that into the traditional RF realm, which quite frankly has not kept up with the speed of the digital side. Because you're working with digital components, data feeds and so on, you don't have the heavy RF architectures associated with the traditional arrays. You can, transport data in fiber links, what traditionally was in waveguides. There's a lot of others, as mentioned, being able to condense the size of the circuits into small footprints. As Caleb mentioned, doing all kinds of processing of beams to create adaptive beamforming and so on, and with quick and very agile way. Dynamically, as you are receiving signals, you can change the forms of the beams and transmit and so on. So there's a lot of advantages. Some traditional architectures do have their advantage. In some cases, they can be more linear depending on the design. And, there are some diehards that think a hybrid combination, perhaps from a cost point of view, is better. And, there's a lot of discussion in these areas, but I will say that it's evolving more toward digital processing.
Mm-hmm. Dr. Hurd, how do the higher levels of digitization impact the cost of phased arrays in the future?
Digitization, as you can see, brings a lot to the table, and it moves a lot of the functionality from the analog to the digital portion. It will be very dependent on the bandwidth, the dynamic range, and the number of beams. The processing technology at any given slice of time will dictate how many beams can be processed and at what bandwidth. And there are some very basic advantages of taking the beamformers out of the analog system. You could save money by removing those because they are a direct cost on material and the labor. I think so. I think it's very dependent on, again, the demands of the number of beams and the bandwidth. At this time, I think the CR in the processors can support sort of hundreds of megahertz and tens of beams throughput. And as it goes along faster, we'll have more of those to use, and that'll be the tipping point.
So what do you think then is the next big challenge in phased array technology, and what kind of capabilities do you think it will bring?
This digital architecture that you're seeing here emerge gives us a lot more flexibility, and as Caleb showed, just the adaptivity and the ability to reconfigure. I think the area of multiple function arrays, where you'd like to be able to use the aperture to do multiple things simultaneously, share the resource, is probably the next area that we're going to see a lot of technology development. It means we're going to have to learn how to operate asynchronously at the array level, meaning simultaneous transmit and receive, and that introduces a lot of challenges in terms of maintaining isolation and cancellation in order for the signals not to interfere with one another. So I view that, I think many of us in the phased array area view that as being the next big challenge, is multifunction, sort of simultaneous use of an aperture.
Dr. Fulton, what are the remaining barriers to ubiquitous digital arrays? Could you just share thoughts about that?
I think one of the traditional barriers has been just the perception that there's too much data to deal with. Being systems where petabytes per second of information are being processed, systems where for cost reasons you're actually going all digital instead of analog just because of the requirements on the number of simultaneous beams. I think one of the biggest issues and barriers left is, and Dr. Hurd mentioned this a bit, is the amount of control, low-level control, not just high-level radar control, as is evidenced by the existence of multiple open architecture type standards, but how to distribute a low-level control and organization to systems where instead of having, say, 16 or 32 bits of control per element, like an analog array might have, 6 bits of phase, 6 bits of amplitude, and a couple other bits of control. We're seeing systems now with kilobits or even kilobytes of reconfiguration space and tunability at the element level. And the control of those of these really advanced architectures needs to be to reap the benefits of what might be possible with these types of systems. So I think there are an awful lot of software-related challenges just doing the straight beamforming and implementing what a traditional analog array would do in a more reconfigurable way.